Last year, I put the Razer Blade 18 up against my MacBook, and it was not even close.
Even the M4 Pro beat it? Come on.
Well, this is the new one, and this got the RTX 5090 instead of the 4090, 24 gigs of VRAM instead of 16, and a brand new Core Ultra 9 from Intel inside. And even the stickers have been updated, so it's gotta be better, right? Well, that's what I want to find out, because last year, my complaint wasn't how it was slow, it was more about what you got for your money, because these machines are expensive.
How can Razer charge this much money? I don't know.
Now, I don't want to get too much into synthetic benchmarks, because they don't really mean much, but they are a good indicator of where things stand. So I'm gonna run Geekbench 7 this time, and right out of the box, the Razer comes in balance mode, and it's also unplugged. By the way, Geekbench maps to stuff you really feel all day long. For developers, single core will be like your editor, that's the typical latency, your language server, that's TypeScript checking your types, and that's whether the machine feels snappy or feels like it's fighting you. And the multi-core score is everything you wait on, like builds and compiles, running test suites, Docker spinning up, your bundling for production. And the thing that matters a lot for a laptop specifically is you're going to be taking it places. So you're not always going to be plugged in. Now this is the Apple MacBook M5 Max, and the energy mode usually comes on automatic. So it kind of allocates the resources where it needs them. I did set it to high power, so let's run that. I know you're going to say, oh, Alex, it's not fair. This one is balanced and that one's high power. Don't worry, we'll run this high power also. There's just a couple of different settings you need to tweak here. Also, while it's running, just to address some of the comments from last year, yeah, this is a gaming laptop and this is a productivity laptop, but you can also game on a Mac and you can game on this. The Razer will give you a much better gaming experience, and also most people I know are not gonna buy two $5,000 to $6,000 laptops. They're gonna buy one. So if this is the one you're buying, you're doing your productivity stuff on it and you're gaming on it. And you wanna know how it behaves with productivity too, to see what you're getting or what you're not getting. Here's what you're getting unplugged. Single core score, 1,840, multi-core, 15,118. It's not amazing, which is why for the rest of this video, I'm actually gonna have it plugged in. Now with the Mac, it doesn't matter if it's plugged in or not. It's constantly using full power like I set it to. But with this one, I think we can get an improvement. I plugged it in, and I'm also going to set this to high performance. There's two places where you can actually do this. One is right here in settings under system power, and then you can set this to plugged in best performance, on battery best performance, or you can pick and choose what you need. But there's also another way to get high performance power plan, not power mode, and that's in the control panel under power options. Right now it's set to balanced and it doesn't give you another option to set, but you can do it through the command line. Just go to the terminal as admin and you can run power CFG, power config, duplicate scheme. You have a long GUID. I'll put that GUID down below for high power mode. You basically duplicate that scheme. In this case, I duplicated the ultimate performance scheme, but it's going to be high power. And then power config set scheme min, boom. You have to back out and then go back in. Now you have high performance magically there and select it. It says favors performance but may use more energy. Now I have to say that last year when I plugged the Razer in, it started spinning up its fans, going crazy. This year, this is a very quiet machine. I'm actually pretty impressed. Also, when you set high performance that way, power mode is no longer selectable. So it's going to be set to best performance all the time, which is the way I like it. I'm going to run Geekbench one more time. It finished. And I gotta tell you something here, because I actually ran it two different ways, and this is a big change from last time. One way is under high performance, just like I showed you. These are the scores. Single core, 2,918, multi-core, 24,149. Really good. I also ran it under balanced again, and that gave me 29,008, 23,957. Essentially the same scores, high performance or balanced, and what matters more here is that it's plugged in or not plugged in. That's what makes the big difference. So let's take the higher of the two, which is this one, the high performance one, slightly higher, and compare it to the Mac. Wait a minute. 3,220 on single core and 22,658 on multi-core. Well, that's not actually true. That's inside a Windows 11 virtual machine running inside the Mac. So we got 24 cores here on the Razer machine and 12 cores in a virtual machine on top of Mac OS. And it's within 6% of the real thing running on bare metal with 24 cores. I'll do more virtual machine stuff a little bit later to do some Visual Studio tests, but here's the actual score on the Mac itself. 3,756 for single core, 34 5,623 on multi-core. That is crazy.
I don't expect one AI prompt to build an entire project for me. In reality, I'm constantly moving between models depending on the job. GPT for research, Claude for coding, Gemini for massive context, Nano Banana, Midjourney, Flux for images, and then I've got Seed Dance and Kling for video. That's why Chat LLM by Abacus AI makes sense. It brings day one support for the latest GPT, Claude, Gemini, Grok, DeepSeek, and more in one place the moment they drop. Pick any model from the interface or let Route LLM automatically choose the best model for each prompt. Create professional presentations with graphs and charts and deep research detailed content. Need human sounding copy? Humanize rewrites text to defeat AI detectors. Need visuals? Pick frontier or open source models. And when you need more than chat, Abacus AI Agent can help build complex apps and websites, connect payments, or run 24/7 agents that keep working through longer tasks. The best part is app hosting. Backend database and auth support comes with the subscription. All that starts at just $10 a month, way cheaper than paying for all those subscriptions separately. Check out chatllm.abacus.ai or click the link below.
Moving on. Now this one runs right in the browser. Boom. Now I know that some of you are thinking, I don't do web development. Why should I care? Well, here's why. This test speedometer runs real framework loads, React, Vue, Angular, this stuff a lot of us actually ship. I'm a web developer, that's the kind of stuff I work on. But here's the part that people miss. If you are running VS Code or Cursor or Windsurf, even if you're not doing web development, you're already using the browser. That's Electron. So this score isn't just websites, it's your editor. It's your dev server, your dev tools with 30 tabs open, tab switching between them quickly. That's most of your day. 48.3, that's actually the best score I've seen on a Windows laptop. That's really good. Last year's machine got 23. On the Mac, it's 49.4, so they're basically the same. That's actually surprising. Oh, oops, that's in the virtual machine again. Okay, fine, I won't do that trick anymore on you. That's more like it. 63.5 on the M5 Max here. It's very hard to beat an M5 chip here. Apple has been the leader in single core performance since Apple Silicon came out back in 2020. But I want to be clear here that almost 50 is really good for a Windows laptop. On a related note, this is the web tooling benchmark from the V8 team. Yeah, that same V8 that created the JavaScript engine. And boom, let's go. Now this is your typical JavaScript stuff from 8 years ago, the stuff that was popular back then, but some of it still is. Babel, TypeScript, parsers, minifiers. There's no disk access and no I/O here. This is pure stuff here. And this is the first time I'm hearing the fans of the Razer spin up a little bit. It's still a very quiet machine, not like last year's, but I'm hearing them. And we're very close now. Babel, 39.6 runs per second on the Mac, 34.4 on the Razer. CoffeeScript, 37.2 on the Mac, 26.06 on the Razer. And TypeScript, the one I care about the most, 53.39 on the Mac, 47.29 on the Razer. Very close. Geometric mean, 41.9 versus 35.99. This is actually very good. Did I mention that I always thought of the Razer as kind of like the Windows equivalent of a MacBook? It's solidly built like a tank, all metal, and this one being an 18-incher really feels like what a MacBook would be if it was 18 inches. The keyboard on the Razer is also very good, and I appreciate this little fact. They centered the trackpad even though there is a numpad here. Some laptop makers don't do this. Anyway, I'm getting a little bit off track here. We're still doing performance tests, but I'm thinking a little bit about hardware, and specifically the SSDs that are inside here, because the Mac took a giant leap forward with this new generation, because now they're doing Gen 5 drives. Oh yeah, that's a very different kind of drive inside there. It's pretty much 2 times faster than the Razer. Now, the Razer is no slouch. Last year's Mac model was pretty much the same numbers. We got sequential read speeds of 7,000, 6,300 for writes on the Razer, and 13,769 read speed, 13,555 write speed on the Mac. Sequential means basically you're just taking one large file and just dumping it. But what about this other number here, the RAM random. Developers care about this one because it kind of represents compiled code. And on this one, the Razer does a little bit better than the Mac. So this is going to be important because when you're doing compilations, you're not only using that processor, you're also doing a bunch of disk I/O. We'll see that at work momentarily. But I also want to see how it does with external read and writes, since both of these have Thunderbolt 5. Identical drives inside. I got the 9100 by Samsung, which is the Gen 5 drive. It's one of the fastest things you can get right now. Of course, the Mac has 3 Thunderbolt 5 ports. Razer has just the one. So let's see how we do here. The reason this is important is because, well, when you're buying a Mac, you are stuck with what you have. So you kind of tend to buy the more expensive models because you might run out of space, or you might just say, fine, I don't need the really high-speed internal drive that the new generation provides. I'll just use an external drive, and that's plenty fast already. And here we're seeing the numbers dip quite a bit on the Mac. 6,960 for read, 6,600 for write. The random numbers are actually about the same, but on the Razer, we are seeing quite a bit of a dip, especially on that write. 4,000 or so on read. I'm gonna do that again because that seems really low. 1,300 is what we got on write, which is just kind of pretty low. The read speed repeated the second time, and write speed is about 1,300, so not great. Now, some of you might have noticed that I had this plugged into the left side. By the way, these ports are not labeled. There's a USB-C port here, and there's one on the right. They're not labeled. You have to know that the one on the right is the Thunderbolt 5 one. And sure enough, when I plugged the external drive into that, ran this again, I got a higher read score for sequential, but the write speed, 1,300, again, really? Better random score on just this bottom one, but overall random score is lower than the Mac. So they still have some work to do as far as their Thunderbolt support. And this is an Intel box, so they need to get a move on that. Speaking of moving on, I'm gonna move on to some multi-core tests. This is the Mandelbrot algorithm implemented in Python, and it's a pretty intense algorithm. It uses up all the available cores and just pegs them to the max. Now I'm going to send the 1600 parameter and send the rest to dev null. We don't see output. I'm using the time command on the Mac and the measure command on Windows in PowerShell so that we get the timing of each one. And let's go. And now I twiddle my thumbs. I usually cut this part out, but hey, it's done. Wow, okay. It's fast on both of them. That was only 11.3 seconds on the Mac and 13.5 seconds on the Windows machine. Both really, really fast. By the way, that's what it looks like when running on the Windows machine. Every one of those cores was pegged to the max at that point in time. And just so you can see what it looks like on the Mac, here we got 12 performance cores and 6 super cores. You can see the green soldiers marching. That's basically what it looks like right there. Very similar pattern. All the cores are being used, but we got 6 less cores on the Mac than we do on the Windows machine. Now let's do some compilations. Damian Edwards created this repository with .NET compilations. Damian Edwards is an architect on the .NET team, and it's called DevBench. Now this one has a couple of different options to run it. There's a Hello World, which we're gonna start with, and it's a small little .NET application build. Shouldn't take long at all, and I suspect that the Razer is gonna win. And as I was saying that, it actually finished, but the Mac won. So what's nice about this benchmark, we're gonna do it again, don't worry, is that it does a cold build, a warm build, and then an incremental. And on each one of those, the MacBook won. Okay, so Hello World didn't work out for us on the Razer side. Let's try this next one, which is actually a large .NET project that's 100,000 classes and namespaces. Boom. This is gonna take a little bit longer, not that long, but this represents a pretty large project, and we're gonna do an actual build of a real project next. All right, the cold build finished in 45 seconds here on the Mac. Warm build, 8.9 seconds. And you can see how it's hitting the CPU cores. It's kind of all over the place. That's why this is a more realistic example of an actual build. And this is using the disk. Whoa. Not what I expected. 56 seconds for the Razer for the cold build and 15 seconds for the warm build. 2 times longer. All right, let's do one more. This is the real CMS project called Orchard. And by the way, this repository is available. You can clone this yourself and build it yourself if you want to. Try it out on your system, see how it goes for you. I'll link to it down below. Yeah. So this This proves it. Cold build on the Razer took 42 seconds, a warm build 9 seconds, and an incremental 7.9. Everything is faster on the Mac. 21.8 seconds for the cold build, 2 times faster. The warm build 6 seconds, and incremental 5.9. This was kind of like the test that I really thought that the Razer would win this time, but it did not happen. But there's still something that Razer has in its pocket that might redeem it. And that's that RTX 5090. Now I did mention we'll get back to Windows and Visual Studio. So here I have Visual Studio, which is a Windows only program since Visual Studio for Mac was executed a little while ago. Let's see how long it takes to create a new project. Last year, if you remember, if you saw that video, it actually was faster to create a new project and to start it up in a virtual machine on the Mac instead of Windows. So let's see. I'm on the last step. I'm gonna hit create and we'll see which one pops up first. Come on, come on. It's creating. Oh. I think that this one actually did it. NVIDIA usage collection, which is, don't know what that was all about, but it seemed to me like the Razer actually created the project faster. Not that much faster, but faster. Of course, this creates a Hello World Blazor application, and boom. And we should get some questions if they didn't fix that yet. Yeah, there we go. Project configured to use SSL. Don't ask me again. It's gonna ask me again. It's gonna ask me again. Yes. Yes. Don't ask me again. Notice a pattern? Boom. And one more time, 4 times, boom. Now we're waiting for that browser to pop up. And yes, the Razer actually wins this one by quite a bit this time around. Nice work. That's how quickly it's supposed to pop up. I'd like it faster, of course, but you know. Now let's do a subsequent build because it's already warm and boom. Now they're about the same, but I think Razer's just a tad bit faster. Ladies and gentlemen, we're gonna do some AI. I'm gonna kick things off with a very simple test. We're gonna do LM Studio, and this is Qwen 3 4B, the multimodal version. And here I've got the MLX version. Here I've got the GGUF version, but they're both 4-bit quantizations. I'm running MLX on the Mac because that's optimized for the Mac. Let's crank up that context length to 262,000, load the model, and try my first prompt. Hi. Boom. Hi, how are you? Oh my gosh. What happened? 25 tokens per second? There's something wrong here. It's 181 tokens per second on the Mac. This is a small model. It should be way faster here. Let's give LM Studio a kick in the butt and try this one more time. 21.9 tokens per second. And this, I'm afraid, is the limitation of the amount of memory we have. If you take a look at the GPU here, you'll see that it is running on the GPU, but it's also using up all the available memory of the GPU. Right there, 23.5 out of 24, and some of that stuff is spilling over to the CPU. That's why it's taking a while. While we do have 24 gigabytes of VRAM available here to use, the context size that I specified eats all of that up. The estimated memory usage, LM Studio is telling you right there, all of it. All of it. So I need to lower the context length to something more usable. I don't know, let's go with 68,000. Ah, now we're cooking. Hello. I know you're sick of my small prompts, but it proves a point. It shows you, at least right away, how fast things are going. So context length definitely matters here, and we're reaching about 129 to 160 tokens per second. For some reason, it's not getting consistent results. Here's 168, not bad. Here we're getting 181, and I specified the full context length of 262,000, and the reason this is able to do it without even blinking is because this Mac has 128 gigabytes of memory, most of which it can share with the GPU. And I've made many videos about that. Unified memory is what it's called. It's where the CPU and the GPU draw from the same big pool of memory. Well, on this computer, it's a big pool. MacBooks also come in 16 gigabyte varieties where they don't have even as much as this machine. So that's MLX and LM Studio. Now I did also run slightly larger models, and I ran the GGUF versions in Llama CPP, which is probably the most popular way to run your models right now. I mean, unless you're serving VLLM and a lot of users. That's a topic for another day and not related to running local AI on your machines. You can see my other videos with bigger boxes for examples of that. For now, I can see that prompt processing, which which is the initial phase of inference, is much faster on the Razer when it comes to Gemma 4 12B, Qwen 3.5 27B, which is a dense model. That's why the numbers are a little bit lower here, and Qwen 3.6 35B, another mixture of experts. That one has 4,235 tokens per second for prompt processing versus the max 3,215. And finally, token generation. Again, the Razer wins here, and it's not even close. Qwen 3.6, 169.1 tokens per second on the Razer, 95 tokens per second on the Mac. And you can see Gemma 4 and Qwen 3.5 here as well. Last year, I said this machine couldn't justify its price. This year, on this test, it absolutely does. But the Mac has another trick up its sleeve. Here, I'm spinning up Llama CLI, and I'm giving it a prompt on the terminal, but notice the model I'm using. Qwen 3.5, 122 billion parameter model, and it's printing out pretty fast. We're getting prompt processing of 139 tokens per second, generation at 47 tokens per second. Right now, 94 gigabytes of memory is being used on this machine, and there's that GPU, that blue line right there, that's the GPU usage during the generation. There's no way that any laptop can touch that kind of model unless you have a Strix Halo machine with 128 gigs of memory, or if you go to the desktop and you have an RTX Pro 6000 GPU. But a 5090, even a desktop 5090 with 32 gigs of memory, will not be able to run a model that large. So overall, the Razer is a pretty impressive machine this year. You win some, you lose some, depends on what you're working on. If the things that you do on your laptop include gaming and AI work, then this is definitely a good laptop to get, especially because this year it's well built, it's quiet, very quiet. It's got a beautiful screen. There are, of course, things I dinged it for, but here's a thing to watch out for. If you're shopping, make sure that you're buying the 2026 model with the Intel Core Ultra 9 290HX, not the 2025 edition, which is gonna disappoint you, I think. You're curious about how the M4 Max does against the 2025 version? Watch the video here. Otherwise, thanks for watching, and I'll see you next time.